Our resources speaker is none other than Engineer Kennon Monleon. So he is a registered mechanical engineer, used to work as a design engineer in a car designing firm, solutions specialist for CIM Technologies, and lastly, certified Solid Edge mechanical professional level. Let's all welcome Engineer Kennon. Sir, good morning.
Good morning, everyone. Okay, so let me share my screen first.
Go ahead, sir.
Yeah. Okay. So welcome to Jumpstart your career in design engineering with Siemens Solid Edge software. So let me show you first a short clip featuring best of the best companies who are using Siemens Solid Edge for the past years. All right, so the video provides another view of the diverse set of manufacturers who are using Solid Edge to improve their product development process. And once again, I'm Kennon Monleon. I'm Solution Specialist for CIM Technologies, and here's my agenda for today. I have Siemens overview. I'll discuss briefly why we partnered with Siemens. Then Solid Edge portfolio, I'll discuss what's inside Solid Edge. I also have the Solid Edge demo and certification. Then finally, we'll proceed to Q&A portion. Now, let's begin with Siemens overview. Siemens' success story begins with the Pointer Telegraph, the 10-man company called Telegraph and von Siemens and Halks began its operation on October 12, 1847 in a building in a backyard in Berlin. So today, yun yung tinatawag nating garage startup. And this is the founding of Siemens. So founding of Siemens is between Industry 1.0 and Industry 2.0. Siemens has played an important role in shaping industrial revolution since being founded in Berlin in 1847. So currently, we're now in Industry 4.0. These are some of the milestones ng Siemens throughout the years, especially with Siemens 2.0 going to Industry 4.0. And in 2016, MindSphere introduced as the digitalization solution for all industries. And today, Siemens is a global powerhouse shaping the future and one of the largest companies in terms of footprint in the world. Being one of the largest producers of energy-efficient, resource-saving technologies, Siemens is a leading supplier of systems for power generation and transmissions as well as medical diagnosis. In infrastructure and industry solutions, the company plays a pioneering role. Siemens is number one, not by revenue, but in terms of most admired company in the world. Siemens is also a leader in STEM education globally. And yung headquarters niya is located at Texas, USA. It is a conglomerate company, a corporation made up of several different and independent businesses. And Siemens Software is under Sony Digital Industries and strongly focuses on the areas of electrification, automation, pati na rin sa digitalization. Siemens for the past 15 years invested more than 10 billion euros in bringing in new functionality. When you see, in fact, Siemens is one of the top 10 software companies in the world. Companies like UGS, Mentor Graphics, and Mendex are some of the companies that acquired by Siemens. And meron din partnership with Bentley. Now let's proceed to Solid Edge portfolio. So this is the evolution toward Industry 4.0. Now every industry revolution, there is an exceptional complexity. You'll see here the red circle indicates the degree of complexity sa fourth industry. Industry 4.0 is the next step after nung three previous industrial revolution stages from water and steam power to mass production papunta sa electronics and automation. And Industry 4.0 focuses on digitalized value chains. Now, it's clear when we look around us, people are looking for a better future with more personalized and safer products. So, fueled by technology evolutions, product innovation is at an all-time high, and we are confronted by explosion of complexity to cope with those expectations. Now, compounding the situation are the conventional pressures of time, scope, quality, and cost. However, in the face of increasing complexity, these pressures are even more challenging to navigate. And this is the product lifecycle management. Yung gray curve indicates the typical product lifecycle, and ang objective natin is to shift the curve to the left. Ayun yung orange curve. So we're actually minimizing the design cost and time while increasing the market success and lifespan ng product natin. Now, to achieve this complexity of product lifecycle, the solution is Accelerator. It is a portfolio covering all aspects of our product lifecycle from product design, product manufacturing, and product performance. Now, we need to go digital to manage yung complexity ng ating design, and Accelerator helps customer to embrace complexity and use it as a competitive advantage. And this is the summary of Accelerator from product design, product manufacturing, to product performance. And it is important to get the feedback from the product performance to determine if we produce a good result. Also, it is called a closed-loop manufacturing. Now, Solid Edge is part of Accelerator portfolio. Solid Edge is also a portfolio especially for mainstream engineering or small and medium businesses, covering many areas for our product design from 2D, 3D, electrical design, simulation, manufacturing, application, and data management. And Solid Edge is future-proof because it has many complementary products. And one of the biggest technologies that Solid Edge has is yung para-solid kernel, which is used by other CAD software on the market. And the exchange of data across different industries to be as seamless or as little problem as possible. And by the way, it is owned by Siemens. And Siemens developed technologies for Solid Edge. First is the Synchronous Technology. It is actually based from two different approaches, history-based modeling, pati na rin yung direct modeling. And Siemens combined these two methods and also added useful capabilities, and yun na nga si Synchronous Technology. And the second one is Convergent modeling. Combination naman siya ni BREP or yung solid model natin and mesh model. So, Ginagamit itong convergent modeling and reverse engineering, generative design, and additive manufacturing. So, our solution lets you use yung ating mesh model in workflows with no data conversion and all the benefit of both technologies. And it all works in a seamless way. Now, this is an overview ng ating Solid Edge portfolio. It is a modular software. You can start with either ng mechanical design premium or yung classic. And if you expand that, you can add on different capabilities such as electrical design, simulation, manufacturing, technical publication, data management, pati na rin yung cloud collaboration. And all of this is integrated and it will work seamlessly with each other. So now the product we're going to work on is from customer master mover. So their products are all about moving heavy loads easily, be it a boat, wind turbine blade, or even a London bus. And this is the workflow we'll follow. Part design, part drawing, legacy and imported data, assembly design, assembly drawing, then we'll do a quick strength test. And ito yung master mover, and then the project in hand is ito, i-redesign tong clamp arm from scratch. Now, first up is part design, and what I want to focus on here is yung real differentiator in Solid Edge, yung Synchronous Technology. Now, here in Solid Edge, we have a ribbon bar consists of different commands na pwede natin gamitin sa ating pagdi-design. We also have these learning tools, help and tutorials, pati na rin certifications. And on your left side is yung design tree natin. And we can also save configuration of hidden and shown parts to make it easier to work on different areas ng ating design. We're going to be designing our part in the context of the assembly using the existing components to help speed up our design process. Now, instead of starting our design with a sketch, pwede natin kunin yung geometry from existing components, and we can quickly capture this and use as a basis para sa ating new model. Okay. Now, to create a cutout naman, we can select multiple existing faces and use Synchronous Technology to push them all the way through the model. And we can also manipulate yung face ng ating geometry using steering wheel. And by working directly sa ating 3D model, instead of having to sketch every feature, we can increase production ng prototype. And a single line can be drawn across this face, so splitting our geometry into multiple regions, which allow us to either add or subtract ng material. Ayan. If calculation is needed, pwede natin ilagay yun sa ating value box and automatically it will solve the equation for us. So we can select few edges that we want to round and enter in the radius. So notice pwede rin natin iselect yung edges na nasa likuran without the need to rotate it. And this is a procedural feature that can be easily edited if kailangan natin siyang balikan. Now, dimensions can be added directly sa ating 3D model at any time to drive the shape and size ng ating features or to help constrain the part and maintain our design intent. So, we have one option here na which driving end na ating select para ma-move yung ating geometry. And notice na nilock ko yung dimension so we can grab the whole geometry. So yung unlock dimension, we can either add or subtract ng material sa kanya. Now we need to create a cutout sa top ng face ng ating model. Now we are towards sa ating dimension as we will use a relationship later on. Ayan. So we can use coplanar relationship with an existing cutout. And then yung depth ng cutout natin can be used yung ating offset face relationship as well. So by editing one of the faces, we can see how Solid Edge using relationship to maintain yung size and shape ng ating model. And now we want to add few more dimension to tweak the size of the model. First, we will add tolerance sa ating center bore as this arm is meant to slide down the shaft and tighten into position. Now, tolerances determine exactly how much room for error we have when we manufacture each part. And then we will add few more dimension to parametrically change yung ating 3D geometry. And because we created some of this geometry without the regard ng dimension or yung exact dimension, we at any point naman can add 3D dimension to finalize our design. And while in 3D, we're actually preparing na for drafting. So these dimensions can retrieve later on, kasama na rin yung mga annotations. And finally, we will dimension the slot width, and notice as we start to change the dimension and both slot change as is our design intent, keep them the same width. Now the next task is to add some mounting holes. Ayan. So notice all the different types of holes we can create from this easy interface, and then lalagay lang natin siya sa ating geometry. And then the clamp assembly will be adjustable. So we want to add some pattern para sa holes. And by using pattern command, we avoid the creation of holes repetitively. Okay, so let's make a drastic change to show you how really powerful yung synchronous technology natin. So by selecting lang nung geometry natin, we can tilt nung geometry by 5 degrees. And finally, we will add some material sa ating model. So Solid Edge has a built-in material library with weight, strength, and density properties included. And you also have the ability to add your own material. Now to summarize, we saw best of the both worlds modeling. Ito nga yung history-based and direct modeling methods. That's synchronous technology. And the robust engine behind all of this is yung para solid kernel natin. And we kept the best bits for our own products. So yung synchronous technology is exclusive kay Siemens software. Now, next up is creating ng drawing ng part natin, and we'll add variety of views to clearly communicate our design, retrieve dimensions directly from the model, and finally add further dimensions and annotation to get it production ready. Now, to create our drawing, we're going to use what is known as quick sheet template, and using this template, it allows us to create drawings with a set of company standard views as well as retrieve associative dimensions and annotation directly galing sa ating 3D model. Now let's create a detail view to magnify small details ng design natin. And a detail view is a partial generated view that shows only what is necessary. So if the detail circle location naman ay nagbago, so the detail view will update, ensuring the correct information is displayed at all times. And another type of view that's popular is yung auxiliary view, which is best to dimension the cutout in the model. Now, auxiliary view is a type of orthographic projection used to determine the true size and shape ng ating inclined and oblique surfaces of part. Okay, and the next thing that we want to add is some center marks. And we may want to have this center marks align with the edges of the part, with the edge of the part. And the center mark command makes it quick and easy to do that. So their basic purpose is to show yung circular pati na rin yung cylindrical features sa ating drawing. Also, we want to add some center lines to areas that have side views ng holes natin. Ayan. So, again, it's quick and easy to just select yung 2 lines natin to make up the holes and place the center line. And by using quicksheet template, most of our dimension were already retrieved from the 3D model. But if needed, we can add naman dimensions ourselves. So, we can use the Smart Dimension command, and Solid Edge will place the appropriate dimension based on the geometry we select. So, we can add angle, use diameter and distances ng holes na ito. So, one tool to do all those different types of dimensions. Now, let's create a feature callout. If we click on a feature such as one of these holes, you can see that it's extracting that information directly from the hole of the part. Okay, and now Solid Edge can of course create your usual section views, but for our final view, let's create a broken out section. To create this, we scribe a spline here sa ating front view. Then tell Solid Edge how deep we want to cut on another view. And finally, we can place the result in any other view. Ayan. And notice how Solid Edge automatically places the correct hatch. So sa broken out section view, it cuts away a portion of part sa ating drawing to view or to expose kung ano yung nasa loob ng ating 3D model. And to summarize, ayan, we saw fast view creation, automated, and production-ready dimensions direct sa ating 3D part with the ability to create further dimensions tweak to your requirements. And all of this clear and accurate to the standard you choose in Solid Edge. It's either ISO, ANSI, and etc. And next up, we'll look at how we can reuse legacy data and convert 2D drawings into 3D models. We'll also explore how to import yung geometry from another CAD package and work with it inside ni Solid Edge. And the first thing that we want to do is open a DWG file directly kay Solid Edge. Ayan. And then for our create 3D command, the first step is to select the views that we want to use for 3D model creation. So dimension and annotation can be retrieved as well. And our final step is to select a location where we want the views to be folded on top of each other. And then mag-move tayo sa ating part environment. Now, Synchronous Technology allow us to work quickly, simplify and select lang ng some geometry and extrude it to a key point on another sketch. So, no need to know yung precise dimensions. So, while we begin to create our part, notice that the dimensions begin to attach directly to model, which save us from having to recreate work that has already been done and also give us the ability to edit yung constraint ng 3D model natin. And to finish up our model, we can quickly add a few rounds and add primitive cylindrical shape to make a cutout. And as I mentioned earlier, all of the dimensions have attached to the model, which allow us to parametrically drive naman the shape and make changes. So on this one, we can make change to this slot, and Solid Edge automatically maintains our symmetrical design intent and moves both slots simultaneously. And diameter and radial dimension can be changed as well. Ayan. For our radius, palitan lang natin siya. And when we brought our legacy design forward, we did it so into a part environment, but we can clearly see that this is intended for a sheet metal component. And by Solid Edge, we can convert this part into sheet metal document. So we can also generate yung flat pattern needed for production. Now, let's open a SolidWorks file directly sa ating 3D model. Now, we can directly change yung ating holes. But here in Solid Edge, we can recognize these holes and to change yung properties niya. Like sizes, standard, pati na rin, we can add thread sa ating holes. Now, if needed, we can add dimensions to parametrically change yung geometry natin. So in this one, we want to make this 50 and we can select yung driving end. We can also change yung radius ng ating 3D model. And finally, papalitan lang natin yung appearance niya. So, ayan. And then simply save lang nung ating SolidWorks file papunta kay Solid Edge. And now we saw how quickly legacy data can be converted to a usable 3D models and how Synchronous Technology allow us to work with non-Solid Edge data as if it was a Solid Edge data. Now for assembly design, we need to assemble yung legacy and imported parts natin that we just created as well as the clamp arm we designed earlier. And addition to assembling the component, we'll look at using fastener system to place standard nuts, bolts into our assembly. Now here in Solid Edge, we can just drag and drop yung ating parts using parts library. And let's apply some constraint. So yung default relationship is flush fit. It applies the most appropriate relationships from mate, axial align, pati na rin planar align based on elements we selected from the placement and target part. And now we can clearly see that we have a gap. Ayan, may problem tayo dyan. So instead, typically we would need to measure the gap, then go back into the part and make the change to correct it. Sa Solid Edge, we use Synchronous Technology. We can simply relate the faces together like we did at the part level, but right here at the assembly level. Now, simply select which face to move and which face to line up to. And so, very quick and accurate. Now, if we rotate naman sa top view, and we can see that we have an issue. Our bracket is too large naman. So with Synchronous Technology, we can effortlessly make the needed edits. And first, let's edit into the bracket in the context of the assembly. And then select the geometry we need to move and place the steering wheel in an appropriate location to make our move. If we turn on yung backend components natin, we can simply line up our slot with the existing geometry, and Solid Edge will take care of the rest. Now, using design intent to keep everything aligned and symmetrical. Okay. Now, for our 3D imported data, so same process, but this time we need to go into the sub-assembly. And then using parts library, we can simply drag and drop ng ating 3D imported data. Okay. And the default part positioning tool, yung ating flush fit, and we can automatically apply mate or axial align relationships based on the type of geometry we select. And we'll use that here to quickly position ng part natin. So by simply selecting this face, papunta sa face ng existing component natin. Ayan. Now we need to place a mirror copy ng ating part on the other side of the model. We can do this using the mirror command, which lets us choose if we want to place a rotated or yung mirrored copy ng ating part. Okay, so instead of dragging and drop the same part, so si mirror command makes it easier to place the part in exact location. Now, if we want to simulate the motion of the assembly, we can do so by dragging the mechanism within its degree of freedom to move. And when it comes to assembly motion, importante to check yung ating interference or if there are any clashes between parts. So this time, merong interference parts na yun. And using synchronous technology, we can edit this part quickly. Move lang natin pabalik yung ating bar. And then, a simple select sa face ng part na ang 3D imported data natin, ang lalabas sa steering wheel. And then using synchronous technology, we can drag this down by 5 mm. So there's enough room para sa ating clearance. And since the parts are mirror copies of one another, so both parts will update automatically. Okay. Now, if we check again sa ating interference check, ayan, so no interference were detected na. And now we are ready to add yung ating jaw papunta sa clamp arm. A couple of relationships will get that into the correct position. And it would be easier to assemble these two components using yung ating axial align from the assemble command to align these two cylindrical axes. And notice how the hydraulic hoses automatically update to the new position. Okay. And we need some fastening hardwares like bolts, washers, and nuts. Now to achieve this stock, Solid Edge has the fastener system. We simply click yung both sides of where we want this stock to be. And then fastener system will automatically figure out what bolt sizes will fit these two holes. If nagamit na natin to dati, so we can save these settings and then use it again. By clicking OK, it will automatically insert yung ating fastener system. And let's look at some options that can help speed up ng ating productivity on this next component we place in our assembly. So, assembly relationships can be saved with the part file so that when the part is placed into an assembly, we only need to choose the faces or axis of the part that we want to constrain to. So no need to select anything on the placement part which cuts our work in half. And another tool to help with part placement is our clone component command. So this command will place multiple occurrences of a part at a multiple locations. So if needed, we can adjust each clone component and either flip, rotate, or suppress them. It also creates assembly relationships so that the manual work involved in placing components repetitively can be avoided, so boosting our productivity. And for our final step, let's look at our caster assembly. Now we need to add another caster for the other side. Ayan, kasi mag-isa lang siya. And we could mirror this. However, Solid Edge provides a quick way to copy components. So first, let's go into this sub-assembly. Now, if you're used to using tools like Microsoft PowerPoint, you'll know that you can simply select what you want to copy and then hold down the control key while dragging to create. Ayan. And then Solid Edge will even automatically create new relationship for these components to keep everything in place. And finally, show lang natin lahat ng ating components. Now, to summarize, we quickly assembled our part into place with the help ng ating automated fastener library. So in particular, eliminating costly interference and experience another great quality of Synchronous Technology, the ability for rapid top-down assembly work and blurring the line between part and assembly design. So next up naman, we'll create an assembly drawing. So there is the same as creating ng ating part drawing, but we'll take a look at some assembly specifics such as yung exploded view, pati na rin yung parts list. Now for the view, let's place an exploded view configuration and shade in the view for a better look. Now to create an exploded view, Solid Edge has tools that look at the mating relationship of the components and then will explode for you, including na rin yung flow lines. And you can of course tweak the result. And we can place parts list with balloons. Ayan, it is customizable. We can add yung size, mass, file name. So you can save your own company standard of what you want to show in your parts list. And parts list is usually combined sa ating assembly drawing as it provides a complete tabular list of all parts needed to build nung complete assembly natin. And so dito kay drawing natin, we also have these balloons that can help us to easily determine the parts and use balloons to label components with their item numbers from the parts list and to reference notes in drawing. So dealing with the balloons, meron din siyang alignment shape. And if needed, we can also modify yung ating parts list by simply double-clicking it and apply some modification. So we can change yung font type. Ayan. Okay. And to summarize, we saw how to place exploded views of our models. So we created automated parts list with balloons. So our final step is to check the strength ng ating clamp arm. So integrated into Solid Edge is a way to simulate this virtually. So it is integrated, we can easily make any required changes and retest as needed. So we'll also look at documenting our result in the form of a report. Now we need to open our sub-assembly and then isolate natin yung clamp arm. Okay. Then we need to add the load sa ating holes. So this is at the bolt location on these two holes. And we can use our trusty steering wheel to specify the direction of the load is in. We'll specify 150 newtons as this is the force required to move our load of 800 kilogram, which the machine is rated for. And the next task is to add any necessary constraint sa ating model. And finally, we need to mesh and solve our model. So basically, what Solid Edge is doing is breaking our part up into elements. So the element in finite element analysis, FEA, and then testing the loads and the constraint on each of these to give an overall result. And it's then going to give us feedback on where the greatest stress is in the part. So we can animate yung ating propagation ng stress. So, however, yung animation na yun is exaggerated. So yung actual niya, halos hindi natin makita yung movement. So that's why mas maganda yung exaggerated view option niya. And then let's check yung ating factor of safety. So we want this to be 4 times stronger, but we can see this that the value is at 3.05 lang. Now we need to modify our 3D model. So luckily for us, we can easily make this edit with the use of Synchronous Technology kay Solid Edge. Now using Synchronous Technology, we simply select these faces and then move lang natin pataas to add a material sa ating geometry. Ayan. So knowing where the greatest stress is, yan, palitan natin tong 2 mm by 5 mm. Okay, now balik lang tayo, remesh and solve lang natin. So fortunately, dito kay Solid Edge, hindi na natin kailangan ng resetting. Simply select lang ng ating solve command and then it will automatically simulate again. Ayan. So let's check again sa ating factor of safety. So we need to set this by 2 and 4 and then makikita natin the value is at 4.74 na. So okay na yung ating model. Now we can create report dito kay Solid Edge by simply clicking yung create report command and then it will automatically capture or yung screenshot ng results ng ating simulation. Okay. Now to summarize, so this is integrated yung simulation for design engineer use. So test for strength virtually to reduce yung physical prototypes. Or if you're not worried about yung product failure, we can find out how much material you can remove from your product and then to reduce yung overall cost natin. And the technology used behind the scene to ensure yung accurate result natin is yung FEMAP and Nastran. Now for Solid Edge certification, and Siemens offers Solid Edge Student Edition. This version is same as commercial license, but of course, file created here cannot be open using yung commercial license natin or yung commercial software. And the 2D drawings has watermarks. And this is free to any active student and should be used for academic coursework. And learning Solid Edge as part of your education, it prepares you to enter the workforce and helps you to stand out in today's highly competitive economy. For educators, you can easily access yung full Solid Edge portfolio, easy to learn, and easy to use software tools for all aspects of the product development process. And additional Solid Edge resources include educator training and problem-based learning curriculum and tutorials to support your classroom teaching. And Stanford IT Learning offers yung comprehensive courses natin for Solid Edge, Fundamental, and Advanced. So we also offer yung guided learning path, prepares the student for certification. Now we have 2 skill level for certification. Number 1 is yung Solid Edge Mechanical Associate, intended for STEM students, and Solid Edge Mechanical Professional, intended for instructors, college students, or individual who have used Solid Edge extensively. Now being certified, it will boost your resume with industry standards And this demonstrates your proficiency and knowledge with engineering technology. If you're a student, it may be a leverage as you seek internships, postgraduate employment, or tutoring gigs. And the good news is all Solid Edge certification exams are free for a limited time. So, you need to download yung Solid Edge na. And last December 2020, ayan, a community of professional designers, engineers, manufacturers, and students was launched here in the Philippines. So you may join by scanning yung QR code or search for Solid Edge User Group Philippines sa Facebook. And for the summary, Solid Edge is part of Accelerator portfolio nga. It also a portfolio especially for small and medium businesses. So covering many areas for our product design from 2D, 3D, simulation, electrical, manufacturing, and data management. Now, here are the growing Solid Edge user sa academic. Ayan, meron din tayo dito sa Philippines. And Solid Edge customers sa Americas, AMEA, Asia Pacific, and then startups global. Now, for more info, visit lang sa solidedge.com. And that's all. Thank you very much sa inyong time.